Okay, I'm going to be talking about race conditions. And race conditions can happen in any system. It can even happen in electrical systems. They certainly can happen in software systems where more than one thread is operating at the same time and trying to access the same data. On Wikipedia, there's a pretty good explanation of what a race condition is. And again, this can happen in any software system, not just Wakanda. But I'm going to show you a case where that came up in my development and how I dealt with it. First of all, let's make sure everyone knows what a race condition is. Here's a good little example from the Wikipedia page. Let's say there's two threads and you have a global integer variable that they're both accessing, and they're just basically going to increment the variable at various times. So if you look at the example, the integer value starts off at 0. Thread 1 reads the value as 0, increases the value to 1, and then it writes it back as 1. Then thread 2 grabs the value, increases the value to 2, and writes it back as 2. That's exactly what you would expect. The final value would be 2. The only problem with this, and this is the race condition, is that this was what causes the race condition. These particular operations, read value, increase value, write back, do not necessarily happen all together within one thread without another thread doing one or more of those things at the same time or before or whatever. So let's take a look at another example down below where the integer value starts at 0 again. Thread 1 reads the value as 0. Thread 2 then reads the value as 0. Thread 1 increases the value to 1. Thread 2 increases the value to 1. Thread 1 writes it back as 1, and thread 2 is going to write it back as 1. So now the programmer is thinking, what is going on? Now, race conditions can cause very subtle bugs. A lot of times they only happen very rarely, and if you can see them before they will happen and deal with them, you're going to have very few bugs in your code because of race conditions. Now that we know what a race condition is, let me show you where I ran into one in Wakanda. I have boiled this down to the absolute minimum for an example, and basically we have a product class, and it's just got one field really as a name, and then each product can be part of other products, basically like a product bundle or package of products. So we have products in this product and products in this product is in. So products in this product is basically like a tree. So products in this product are its children, and products in this product is in are the parents of this product. And that's all facilitated with the subproduct table, as you can see. Now, the business logic behind this is that a product cannot be inside of another product and then have that product as one of its products. So let's say there's a product A and a product B in here, and we add product A to product B. So product A is now product B's child. We could not now add product B to product A, because then product A would be in product B, which would have product A, which would have product B underneath it, etc. So that's a simple example, but anywhere within the tree there cannot be a duplicate to make a circular relationship. So whenever we're going to add a subproduct to a product, we've got to do that check. There's an onValidate event within subproduct, and it's a pretty simple routine. We're not going to go through too much of it, but suffice it to say it's basically checking for a circular relationship with these two functions. It calls it right here, is circular relationship. If it is, then it's going to return an error, circular relationship detected. Okay? Okay, so far this looks perfectly fine. We've got an onValidate event, which should prevent circular relationships from happening, and everything's good. So let's do this. Let's open up a test, and I'll go through this really quickly. First, we're going to clear everything. All products and subproducts are going to get removed. We're going to create a product called A, create a product called B. Then we're going to go ahead and get each one in product A and product B, make sure we have those. Then we're going to attempt to add a subproduct. We're going to attempt to add A as a subproduct of B. And when we're done, we're going to just display all of the subproducts. All right, let's see how this works. Let's go ahead and run it. And right after it checks for the circular relationship in the onValidate, I put a little debugger statement in there. For this particular purpose where we're not going to have any other threads running, it doesn't really matter, so I'll just go ahead and hit continue. And let's see what the result is. In the subproducts table, we now have product name B as a subproduct of A. That's exactly what we were looking for. Now, let's say we do the same thing without any of the cleanup or creating new products or anything, and we simply just get product A and B and try to add B to A now. That should be illegal because A is already a part of B, so B cannot now become part of A. So let's go ahead and run that. And right here at the save, we get the new entity of the subproduct database class cannot be saved. And what's the reason? If we look at the error over here, we see circular relationship was detected. So everything worked just as expected. And let's go ahead and display our subproducts now, just to be sure. There we go. Product A is a subproduct of product B, and there's no reverse relationship now. So onValidate did its job. Essentially, what we just did is the first part of the example on the Wikipedia page. If you remember, everything was fine because the two threads did not overlap in any way. Now let's see what happens when they do overlap. So let's go back to the original method, original function, and we will start all over again, clear it, create new products, and try to put A into B. Let's run it. Now this time we've stopped inside of the onValidate, and we have already checked saying there is no circular relationship, so we're right here. We have not actually saved the product in the subproducts class yet. So let's go over to our other method, and it's going to try to put B into A at the same time now. Let's run that. It too hits the same spot. Let's go ahead and run the first one. Let it go through. But that was the second one actually. Now we'll try to run the second one, and they both get through. That is an example of a race condition. If they happen to hit at those particular times, this is what's going to end up happening. You've got invalid data now. You've got subproduct B. B is a subproduct of A, and A is a subproduct of B. That's what we were trying to avoid with the onValidate. So just doing an onValidate is not going to do this properly. Now you might be thinking, what about putting these inside of transactions? Would that do any good? The answer is actually no, and it actually could make it even worse. But let's try it. Let's see what happens. Now we're going to start a transaction, then attempt to add the subproduct, and then commit the changes. So let's see what happens if we do that. So let's run it. We're at our debugger line. Now we go to the other, and it also has the same transaction code. Run that. And let's go ahead and continue. And we'll switch to the other context. Continue there. And as you can see, A is a subproduct of B now, and B is a subproduct of A. So adding transactions in didn't do us any good at all. Okay, so how do we do this the right way? Well, we use Wakanda Server's Mutex global object. And Mutex is basically, it stands for mutual exclusion, and it can prevent one thread from doing something that another thread doesn't want it to do while the other thread is working with a particular thing. So it's a way to keep threads from basically stepping on each other, which is what's been happening to us. So here's what we're going to do now, is we're going to lock the mutex. Now I've got a little module that I wrote called subproduct mutex, and I'll show you why I did that. We could have just used Wakanda's basic object and functions and methods on the mutex object, but I created a separate module, and I'll show you why in a little bit here. And what we're going to do now is we're going to, on the console, show when we lock the mutex, when we're trying to lock it, when we actually have it locked, and we're also going to show when it gets unlocked. So instead of the transaction code, we're going to just put the mutex code in for locking and unlocking in the place where we had start transaction and commit. Let's try this out. Okay, here we are at the debugger line in onValidate again. And if you notice, we've got from thread 1, we said we're locking the mutex, and then we've locked the mutex. All right, so we're stuck at that spot again. That's our trouble spot, really. And let's go and do the second thread. Let's get that running. And it is running, but it's now at locking the mutex, but it can't lock it. It's waiting for it to become unlocked from the other thread. So let's go ahead and continue the first thread. There you go. And if you notice, we did what we needed to do. We unlocked the mutex. We locked it again in thread 2. And then thread 2, since it was forced to do its check on the circular relationship after thread 1 got done with its save, it now found the circular relationship and goes ahead and unlocks the mutex. And if you notice, we just have product A is part of product B. Let's go to our display subproducts, which does all of them, just to make sure that there's not two still. And again, same thing, just product A is a subproduct of product B. That's exactly what we want. There's a couple of cautions with mutex. One is if there's any kind of an error when you have a mutex going, some kind of a exception, you still want to go ahead and unlock the mutex. I don't know what Wakanda actually does if a thread throws an error, an exception, and ends. I assume it unlocks the Mutex automatically, but I'm pretty sure it would do that. I'd have to do some more testing on that, but even if it does, I would still want to have some kind of a try, catch, and do an unlock, even if I come up with an error of some sort. So that's one consideration. And what about transactions? The main thing you have to be concerned with transactions is you have to make sure that you commit your changes and then unlock your mutex. Otherwise, the other thread is going to not see your changes possibly, because if you unlock first and then commit, the other thread goes ahead and locks and could do the checks, not see your changes, do its thing, and then you make the changes with your commit. So make sure you always do your commit, then unlock your mutex. Now let me show you why I needed my own module for the subproduct mutex. In the onValidate function, one thing I'd like to make sure of is that the caller has actually grabbed that mutex. If they haven't, then we're going to throw an error. So let me go ahead and uncomment out this code that's been commented out the whole time. So what this is going to do is it's going to grab my subproduct mutex module, and it's going to call a method from the module that is active. And if it's not active, then it's going to return this error saying that the mutex must be locked first. So if anyone decides they're going to try to save a record in my subproducts class, it's not going to happen because we're going to throw this error. So one way or another, they're going to have that mutex locked. Now, this particular method is not available in Wakanda's implementation of Mutex. So I created my own module to include that. Let's save this. Let's take a look at the module. It's pretty simple. It's got an isActive, it's got a lock, a try to lock, and a unlock, I'm sorry. And that's all the functions that the normal Mutex has, except for isActive. And basically I'm just taking a hidden variable inside the module called Mutex is active, and just whenever I lock the Mutex, it makes it true, and whenever I unlock it, I make it false. So that way the onValidate can now say, is it not active? And it can throw the error. Let's try this now with the same code as before for testing, except we're not going to do the lock. We're just going to do a transaction, and that's it. And let's see what happens. And we get an error, and right during the save, and it's the subproduct mutex must be locked before attempting to save a subproduct. So now we're protected from someone calling save without following our rule of having the mutex locked. I know this wasn't the most exciting presentation of all time, but it is a pretty important part of programming, and I just want to let you see how Wakanda allows you to deal with race conditions in a really nice way.